Okay, so here we have our quad again with some point normals. And what I'm going to do is I'm just going to rotate the back two normals. See, they're rotating down, okay? And you can see that it looks like we have wrecked the surface shading, but actually we've turned a flat surface into a quarter pipe. See, now if I bring this back up like that, you can see now it's like a flat surface. And then if I bring this down like that, you can see now it's almost like rounded, okay? So if I go to our next example over here, what's actually happening is we are interpolating between the normals pointing this way and the normals pointing up over the surface, right? So if I bring these points and I crank it all the way up here, you can actually see how this is interpolating like that from here to here. And by doing that, how light reacts with the surface is, as it hits here, it's like pointing this way, and as it hits here, it's going to bounce up. And that gives us the illusion of this flat surface being a quarter pipe. If we move on to the next example over here, you can see illustrate this a little further. So you can see here that this, again, our quarter pipe, and you can see an actual quarter pipe over here as we're doing it. The lighting is the same, okay? And if we take this line and we morph it, you can actually see that as we go up and down, the normals of the line are staying exactly where they are, right? So you can actually now visually see what's actually happening, right? And if we unrotate these, like that, so they're all pointing up, you can actually see now that this quarter pipe is now acting like a flat surface. If we turn these off, turn the numbers off as well. See, it's like a flat surface. And if we rotate, now they're exactly the same. So you can see how normals affect how light interacts with the surface. So if we move on to our next example, we show our normals, you can see that we have our vertex normals, which are pointing perpendicular to each of their faces, okay? And if I change this from vertex normals, we have a cusp angle of 0. Even if we had a cusp angle of 60, they're pointing because this 90-degree angle is 60 is less than the 90-degree angle. But if we change this to point normals, you'll see what happens here with the shading is our box actually it looks like it's rounded. But it's not actually rounded, as we know. It's just that what's happening is these vertices are averaging in the direction that they're all pointing, right? This point normal is averaging the vertex normal direction. So again, if we go back to our vertices, you can see that this is pointing this way and this way. So this normal would be like that, right? And then if we go over here like this, right? This one would be like that. And then if we go like this, this one would be like that, right? And you combine them all together and you get the average direction of all these normals, okay? And then as we've just learned before, the reason why this looks rounded is because of the interpolation between the averaged and this one pointing directly up. So if we do this, it's kind of like going like this, then as like that, and then this one goes out, and then like that. So we're getting like that rounded shape. Okay, so that's cool. So we can actually go one step further, right? So if I put this back to vertices, right? So we can do that. And if I grab this sphere, okay, I project our points onto the surface, you can actually see how we've moved the actual points. You see here? So if I do this, you can see what's happening over here. Move the actual points. Let me do that and then that. There you go. However, we have not updated our normals. So if I look at our normals, you can see that they're exactly the same. We can update the normals if we go get the normal from the intersection point. So you can see now they're all averaged. But if we don't, you can see how it's a sphere, but it looks like it's a cube. Okay? We can even go one step further. If we take this, and instead of it being the vertex normals, we change it to our point normals, which is averaged, and we do the same thing, you can see now it looks like a sphere, but it's rounded cubes. Okay? And we can even go one step further as well, as if I take this and I bevel it, right? So you can see like that. And then I bevel it again here like this. Okay? And then if I project this onto here, because our normals have stayed, we haven't updated them, we get like this nice beveled kind of cube thing. Okay? So let's go and have a look at this in Maya. Okay, so we're in Maya, and I just have a standard cube that's been subdivided 20 times. Okay? And I have this sphere, but I've put the sphere on a layer, just a standard sphere. Put the sphere on a layer, and I'm templating it because I don't want to see it. Okay? So we can just hide it for now. What I want to do is I want to go to display, polygons, and I'm going to click this button over here and move this up over here. Okay? And if I select this object and I click on face normals, you can see that we have our face normals. Okay? Standard. And if I turn this off and I go vertex normals, you can see that we obviously have our vertex normals. Now, we don't have point normals, okay? And like we do, but we can't just like select it. We actually have to change the angle of these normals. So if I go to soft hard, again, you can see the soft hards. We're talking about if it's split or averaged. And if I change this to soft, you can actually see now we have the averaged surface. So it's exactly how it was in Houdini, right? And if I do the same thing and I go to hard, you can see now we have our split normals, or the hard edges. And if we go to soft hard and I click on the options, we have this cusp angle, right? We spoke about. So I can select this, and we can go apply, we can change this, apply, it's all the same. When we go above 90, apply, and now it'll average and soften them. Okay, so I'm just going to put this back to 20, the default, hit apply. Okay, that's fine. And then I want to take our, yeah, we can just close this. I want to take our sphere. So I'm going to do this, I'll just edit and delete by type history. I want to take this cube and I want to select this sphere, and I want to go to deform, shrink wrap, okay, toward inner, reverse, short. So I want to click this, apply. You can see it expands it out, except we have a bit of an issue. Actually, I'm going to go display, polygon, bring this, turn the vertex normals off. I want to hide this. You can see that this is our object, except it's kind of like done what we want, but kind of not. Like if we do have a look at our vertex normals, you can see over here, it's adjusted them, but because the sphere wasn't like a perfect sphere where the ray hit it to do this, it kind of worked, it kind of didn't, right? But we didn't actually want to inherit the normals from the sphere, right? So all we then have to do is we just undo this. Okay, so we have this. I'm just gonna hide this again. I'm gonna select this, and what I now want to do is I want to go to mesh display, and I want to click lock normals. So what this essentially does, you can see they turn yellow, is whatever happens, there is no way we can change these normals. If I go to soft, it's gonna kind of like do this weird thing. It's essentially locking them, but like, you know. So if I then select the cube and the sphere, and then we go back to project, and I do this again, boop, you can see now, let me turn off the vertex normals. You can see now that we've actually done what we did in Houdini, right? Our normals have stayed the same, and it's essentially a cube in the shape of a sphere, okay? So I'm going to hide this. I'm going to unhide our beveled, right? So we have our nice beveled cube. So it's the same thing. Select this. We have to go mesh display. We have to lock our normals. So beveled cube, sphere, and then just hit apply. And now we have our nice cube that looks like a sphere. Okay, so we're in Blender and we have a cube, just a standard cube that I've subdivided a few times. And we have an isosphere, or just a generic sphere, okay? And if we have a look at our cube, so let's like go into edit mode. And if we go up here, we can select this. You can see here we have we have our averaged point normals. We have our split normals, so you can actually see them differently. They're like separated. And then we have our face normals, okay? So I'm just going to turn these off. And what I want to do, I'm going to go out of here, is I need to duplicate this, okay? So if I Shift D and then right click, and I'm going to call this cube underscore project, okay? Excuse me. So I'm going to turn this off, and I want to add a modifier. So I'm going to go deform, shrink wrap, and I want to project this cube onto this isosphere. So we go target, we do that, so it projects it out. Except if we go into the edit mode and we go into the, where is it? The wireframe, you can see how this is like all wobbly. So we want to change it from warp method to target normal. So it's actually going to use the normal to go out. Then what we want to do is I now need to project this detail onto it's kind of like its projected self, right? It's a different mesh, but it's essentially itself. So I want to then get a another modifier. I want to get a data transfer. So this cube project, we want to go, the source is the cube. And then we want to go to face corner data, custom normals, and I want to change it to topology. Okay, now you see this doesn't work when we're in edit mode. We have to come outside of here to this mode to see it work, okay? And also our cube has to be on auto shade. I think if it's on smooth shade, it doesn't work. Yeah, it has to be on auto shade, okay? So for us to see our normals, so if we want to go inside of this and actually see our normals, we need to apply this. So I'm just gonna go apply, and then apply. Oh, do we have to do it the other way around? I think we have to apply this, yeah, and then apply the data transfer. So now if we go inside here, we can see this, and we can then go to our point normals. And you can see here our point normals are pointing out. And then if we go and have a look at our vertex normals, you can see that these are split exactly how we want them to be split. Okay, so we can also now, because we're not changing the topology this time, we can actually go back out here and go add modifier, data transfer, cube, do our face corner data, custom normals, and topology. And if we bring up the cube and we right click and go shade smooth, if we now do this, you can see that it has inherited the smoothing from our cube. So I think if we go down to here and we do that, yep, there you go. You can see, so it's updated. If we change this to 110, you can see because the smoothing on that cube, so you can see there it's 110. If we just go back to under 90, even if it's like 85, it's fine. If we go 105 or 95, it just needs to be greater than this angle here, okay? So now we want to do the beveled version. So I'm just going to take this, I'm going to duplicate it, I'm going to hide the original, and I'm going to go cube, beveled, Okay. And I'm going to select, so we go to edit mode. Let's turn these off. You can probably all tell I'm very novice at this program. So we want to select sharp edges and then let's hit Control B. Okay. And then the segments, let's go 1. Like that. Then I want to, again, just to add a bit of complexity, I want to, that's it, Alt. Oh. There you go. Shift Alt. Okay. Select these. Okay, are they all selected? Cool. So now we want to Control B. There we go. Just like that, and we'll just add a couple onto here like that. Okay, cool. So we have this, and then I want to duplicate this. So let's go out here, Shift D, and I'm going to go beveled project. Okay, so I'm going to select this. I want to go to modifier, add modifier, deform, and I want to deform shrink wrap. And we want it to be the isosphere. And again, we want to change this to normal. Okay, then I can just apply this. And then I want to take these normals from here. So if I turn our wireframe off, because it inherited the normals from the sphere, I want to project the normals from its original self. Okay, so we want to go add, edit, data transfer, source, cube beveled, and then we go to face corner data, custom normals, and we want to do topology. Okay, so now we can see that it has inherited the normals from its original self. But again, if we go inside of here, we can't actually have a look at them because it's like a post process. So we have to then apply it. So now we can go inside of it to see it. And if we turn off our wireframe is turned off. So I don't want wireframe. Where are you? Okay, I guess we have to. If we go out here, and can we turn on the... wireframe is off. Okay, I guess we keep it. All right, so we want to now, if we have a look at our point normals, it's really interesting here because they're actually like pointing out in the direction of the sphere. Like they're not like pointing in the direction of the points normal, so to speak. But if we have a look at our vertex normals, you can see that they're pointing in the correct direction. But again, if we have a look at it, they're not split. So it's like it's the averaged vertex normal, which should be what the point normal is doing. But the point normals are pointing in the direction of the geometry. And this is... yeah, okay, so it's kind of a bit confusing. You can see why I'm doing this more in Houdini. It's just easier to illustrate this stuff. But there you go. So I've used Blender for all of, a few hours at max. And you can see by just understanding these fundamentals, we can figure out how to do what we need to do.